Today I'm going to talk about how to do simulation for break-even analysis. Fixed costs are those costs which are fixed. They are fixed for 1 year or at least for a quarter. By fixed we mean their volume does not depend on volume of production. Cost of human resources, because we need to hire those people. We cannot hire them today and fire them tomorrow. Capital resources, we cannot rent space on a daily basis. Wages, depreciation, rent, property tax, property insurance, and so on and so forth. Costs which their volume does not depend on volume of production. And then we do have variable costs which their volume depends on volume of production, and we assume, for simplicity, we assume that the relationship is linear, like a line. As we have learned in economics through diminishing marginal return and through economy of scale, we know that these costs are not linearly related, but for simplicity we assume that. These costs are costs like raw material cost, packaging material, supplies, production, water and power, and so on and so forth. Sometimes people make some mistakes and they consider human resources as, or even sometimes capital resources as variable cost. For example, in a very well-known finance book, managerial finance book, I realized that to say, okay, for this technology, labor cost is, say, $30 per unit. For the other technology, it is $20 per unit. In my belief, human resource cost cannot be considered as variable cost, because we cannot, like a piece of cheese, cut them, hire them, and fire them. When we hire someone, we hire him for 1 year, or if not 1 year, maybe 6 months, 3 months. No one can hire people when production goes up and fire them when it goes down. And also in some books I have seen that depreciation is considered a variable cost, because they assume depreciation based on the number of hours the equipment is used, and those number of hours are the number of hours went into each specific product, and then they consider capital cost also as variable. These are not correct. In our school of thought, we differentiate between inputs and resources. Inputs are variable, like natural or process resources, parts, components, energy, data, customer, cash, and so on and so forth. But human and capital are resources. They are fixed. They do not depend on volume of production. So inputs come over here as flow units in form of inputs. They go through a network of value added and non-value added activities, which are run by human and capital resources under an information structure, and those flow units become outputs. In such a system, inputs are considered variable, and human and capital resources. Total fixed cost is fixed. It does not depend on volume of production, but obviously fixed cost per unit of product is variable. It goes down as production goes up. And in this talk, we assume production is equal to sell. Whatever we produce, we sell it. Variable cost. Total variable costs is variable, and it linearly depends on the volume of production. it means variable cost per unit of product is fixed. If this is total variable cost, then variable cost per unit of product is fixed. We show this one by V, this one by V times Q. We show this one by F, and therefore this one would be F divided by Q. Therefore, total fixed cost is here. It is fixed. Total variable cost linearly depends on volume of production. Fixed costs are resources. Variable costs are inputs. And then the total cost will be summation of these two curves. This is our total cost curve. Then we assume sales price is fixed. We do not have market segmentation. We do not have quantity discount. And therefore, total revenue is a linear function of sales, which we assume it is equal to production. Given this introduction, in break-even analysis, we draw our total cost curve. We also draw our total revenue curve, and we have a loss region and a profit region, and the point partitioning them break-even point. At break-even point, we have no profit, no loss. Total cost is equal to total revenue. Fixed cost plus total variable cost, which is V multiplied by Q, is equal to total revenue, which is P multiplied by Q. Therefore, we can put those terms containing Q in one side of equation and have P minus V here, which we also call it contribution margin. It is the rate at which the enterprise brings money in. Why it brings money in? To recover its fixed costs and generate profit. Therefore, break-even point is a point in which this volume of production as sales multiplied by contribution margin is equal to total fixed cost. Before this point, we are losing money. After this point, we are making money. Now look at this simple example to open the stage for our discussion. $100,000. Variable cost per unit of product is $20. Sales price $60 per unit. Therefore, total revenue equal to total cost. 60Q is equal to 100,000 plus 20Q. Therefore, 60 minus 20, which is 40, that is our contribution margin. That is the rate at which the enterprise bring money. So if we multiply it by the units of production at break-even point, this should equate our total fixed cost, and therefore quantity at break-even point is 2,500 for this specific example. If our marketing department expects demand to exceed 2,500, we go for this. It is less than 2,500, we don't go. Around 2,500, for example, from 2,000 to 3,000, we need more information. For example, if our marketing department expects that the demand in future to have a pattern like this, we may go for this investment while we are around break-even point, a little bit higher or a little bit lower. But if they expect our demand to be like this, then we don't go, because future is not bright. And while, for example, now we could be at 3,000, in future we may go under 2,500 and even less, and therefore we do not go for this investment. Now I want to move from this basic foundation to a situation when I want to play with probabilities. Now let's go to Excel and conduct a simulation for this process. By simulation, I mean in reality we cannot say fixed cost is $100,000, variable cost is 20, sales price is 60. It may have a distribution around these numbers. For simplicity, to start our discussion, let's assume these data have a uniform distribution. So they have a lower limit, upper limit, and they are uniformly distributed in between those two limits. For example, in our problem, fixed cost was $100,000. Suppose it is uniformly distributed between $80,000 and $120,000. We said our variable cost is $20. Suppose we don't know exactly it is $20. It can be anything between 10 and 30. Of course, 10 and 30 is a little wide estimate, but just to show the technique, show the approach, let's assume it is between 10 and 30, uniformly distributed. Suppose price is uniformly distributed between 40 and 80 instead of being 60. And suppose sales and therefore production is uniformly distributed between 2,000 and 6,000. If that is the case, then I know my fixed cost has a uniform probability distribution. It is between $80,000 and $120,000. And I know that in Excel and in many computers we have a feature which can give me a uniform continuous random number between 0 and 1. In Excel, if I type rand, a number between 0 and 1 will appear there. And I can generate another one, or I can go down from 5 to 10,004. Now I have 10,000 numbers between 0 and 1. But I don't want a number between 0 and 1. I want something between 80,000 and 120,000. Therefore, I can come here in this cell. Instead of typing rand, I can type 80,000 plus that random number, and I lock A3 because I want to copy it down, so I put $sign in front of it, and then I copy it down. Now these numbers start from 80,000, but unfortunately they don't go up to 120,000, because if I type max of these numbers, enter, if I go there, that max is almost 80,001, not 120,000. Now I was able to create a number between 80,000 and 80,001. What I need to do is to make it possible that it goes from 8,000. So if rand is equal to 0, 0 multiplied by whatever I have over there is 0. But I want when rand is equal to 1, this becomes 40,000, which is the gap between 120,000 and 80,000. I want to multiply this one and look. So now in this cell I have 80,000 plus the gap between 120,000 and 80,000, which is 40,000, times rand. If rand comes out 0, the product will be 0. 0 plus 80,000 is equal to 80,000. If rand comes out 1, the product will be 1 times 40,000, which is 40,000 plus 80,000 would be 120,000. Therefore, I was able to create a number between 80,000 and 120,000 and assume it as my fixed cost. And I can generate 10,000 instances of this number. Let me also make it integer just to reduce the number of decimal points. And for this next line, I can do the same. Here I can say, okay, you want a number to start from 10, correct? Lock it because you want to copy it down, plus the gap between these two, lock it, and this one, the gap is 20, and multiply it by rand. Therefore, one instance of variable cost, which is between 10 and 30, will be generated. I can come here, I say equal to 40, which is the lower limit, lock it, plus the gap, lock it, multiplied by rand. And this is another instance for price, which is between 40 and 80. If you look at all these numbers, they are between 40 and 80. But in order to avoid repeating these computations, let's come and copy this here. If I copy it here, because these A3 and A4 were locked, they are still locked while I have copied them into the new column, which is column B. Still I get something between 80,000 and 120,000. And if I copy this here, again that's it, because those two were locked. Now what I will do, I will go here, A3, row 3, I want to remain row 3, I want to lock it, I want it absolute. But if I go from column A to column B, I want A to become B. Therefore, I can go and remove this $ in front of A. A now is relative, while 3 is absolute. And I remove this one, and I can go here and I remove this one. Now, if I copy this here, a number between 10 and 30 is generated. Let me undo, and let me undo again, and let me go here. I was going to remove $ in front of A. What I can do, I can push F4, and $ in front of A is gone. I can go here, F4, $ in front of A is gone, and F4 again. So now those $ are gone. I copy it down, then I copy it to the right, and then I copy it to the right. So now if I go here, this refers to column C, this refers to column B, obviously that one refers to column A, and this one refers to column D. Copy these things down. Okay, so now I have 10,000 instances of my fixed cost, my variable cost, and volume of sales. Now I can compute my profit, which is equal to contribution margin, which is the gap between sales price and variable cost, multiplied by quantity of sales minus fixed cost, and that is one instance of my profit. I can create 10,000 instances. And as you see, mean, max equal to mean of these numbers is equal to max of these numbers. So in this probabilistic view, my profit can go from negative 86,000 to positive $300,000. Of course, I will be very happy to get this much profit, but assuming that I may experienced this much loss, it may not convince me to go for this operation. Now let me first copy and paste this results, and I paste it by value because I want to do sorting. Now these are not formulas, they are numbers. Then I type here equal to small this array, and I lock it because I'm going to copy down, and 1, the first one. But if I copy it down, that first small will be there. I can type here 1, 2, 3, and then I say small. Instead of 1, I click on this, and then I copy it down. Now this one is referred to the third small, and I can get others. If I go a little bit down, go up, series to 10,000, and in column, okay. And then I can copy down and find the first small, second small, third small. But then I should have this extra column. So what I will do, I will go here. I say find the small of that column. Then I type rows, and then I click on this row, column, and that row again appears. I will go to the first one and make it a 4. So it tells me how many rows are from E5 absolute to E5 relative, and obviously that is 1. The result is 1. Then I copy it down now and copy it down. Now let's look what is the formula. It refers to the same matrix, the same row, but it says rows from E5 absolute to E7. Why? Because in this formula the second E5 was relative, and as I copy it down it becomes E6 and then E7 and so on and so forth. Therefore I can find the first small, second small, and the last small number. And then here I want to find percentages. I type equal to, again I type rows from here to here, but I make the first one absolute. So that is 1 divided by count from here to here, and I make it absolute, right? So that would be 1 divided by 10,000, and if I copy it down, the last one would be 10,000 divided by 10,000, which is 1. These are my x's, these are my y's. I will go here and insert scatter graph, and I choose this one. Okay, so now this is a better understanding of break-even situation. It tells me there are some possibilities of losing money. And if I type equal to count if array, this is the array, condition less than 0, okay, 2242, and then I divide it by count the numbers that I have, and we know number is 10,000. That's it. Now I go here and I type equal to probability of failure is equal to quotations and this number and quotation percentage quotation, should have multiplied this one by 100, multiplied by 100. Probability of failure is 22%, and I want to put it into the title. So I will go here and I say equal to, click on this one, enter. Go here, equal to, and I click on this one, enter. So in this project, probability of failure is 22%, which is quite high. Right? You may play with this graph and make it. Now let's see what we did and try to get some idea about how I can extend it to normal distribution and also to exponential distribution. This was the situation we had. For example, regarding the fixed cost, my fixed cost was uniformly distributed between 80,000 and 120,000, and therefore this height was 1 divided by 40,000, because this is 40,000 here, and 40,000 multiplied by 1 over 40,000 is this area, which is supposed to be 1. Okay, we had a problem in which I should generate a number between 80,000 and 120,000. I know in computer or in Excel I have something called rand that creates something between 0 and 1. So what I did, I said I should go from 0 to 80,000, so I wrote 80,000, plus I should go through the gap from 80,000 to 120,000, so that was 40,000 times rand. This was my formula, but I could have looked at it in a different way. I could have said, okay, this is the probability distribution, right? This is my probability distribution. I want to find a random number in this range, correct? How can I find a random number in that range? I know that no matter what that random number is, suppose it is u, it is associated with this area. Probability of x being less than or equal to u is equal to that area. Correct? Okay. And what is that area? It is u minus 80,000 divided by height, and the height I just said it is 1 over 40,000. And what is that probability? Is equal to u divided by 40,000 And what is this area? What is the characteristic of this area? What is the characteristic of this probability? What is the most important feature of this probability? The most important feature of this probability, it is less than or equal to 1 or greater than or equal up to down to greater than or equal to 0. It is in a range between these two, between 0 and 1. And if it wants to be a random value, I can assume it is equal to rand. So each rand is associated with a probability. As soon as I have that probability, I can use that probability and find U. So the area is this much, and this is equal to a number between 0 to 1, which I assume is rand. Therefore, U minus 80,000 is equal to rand multiplied by 40,000. And therefore, U is equal to 80,000 plus 40,000 times rand. Given this idea, okay, now let's go to normal table. Okay, now let's go to normal distribution. This is a normal distribution. Suppose it has a mean of mu and a standard deviation of sigma. Just for simplicity, suppose this is 20 and this is 100. And we want to generate a random variable from this distribution. So I close my eyes and I put a cross here. This is a random distribution. If I could have closed my eyes and put a dot around there. But what is the feature of this probability distribution? The feature of this probability okay, this is a general normal probability distribution. Suppose its mean is mu and its standard deviation sigma, and for simplicity, suppose mu is equal to 100 and sigma is equal to 20. Now I want to generate a random variable from this distribution. Suppose I can close my eyes and randomly put a point over here. This is an x of this distribution. But what is the characteristic of this x? What is the most important feature of this x? The most important feature of this x is this area, which is from infinity up to x, is something between 1 and 0, right? And I also know that each normal variable is associated with a standard normal variable, where standard normal variable has a mean of 0 and a standard deviation of 1, right? And this x here is associated with a z here. So if I have this probability, I can look for this probability here, for the same probability here, find the corresponding z, and then transform z back into x. And the one important characteristic of this probability is it is between 0 and 1. All probabilities are between 0 and 1. So, if I go and generate a random number and associate it with this probability, then using that probability, I can find the corresponding z. As soon as I have z, I can use the formula z equal to x minus mu divided by sigma. And then x would be mu plus z sigma. I will summarize the procedure. Generate a random number. Assume this is a probability. Probability of z being less than or equal to a specific value z. Random variable z to be less than or equal to a specific value z. And that is equal to rand. Because you have this probability, you can find z. This can be done in Excel or using the table. So you can find z. After you generate the random number, you can go over there, find z. Now you have z, you can go from z to x, which is equal to mu plus sigma times z. Therefore, for example, if rand comes out 0.5, that will correspond to z equal to 0, right? And if that is equal to 0, x would be equal to 100, which was mu, plus 20 times 0, which is 100. So you use this rand of 0.5, you created the z, using z you created x. I will explain it in Excel. I still assume that the fixed cost has a uniform distribution in between 8,000 and 120,000, but I assume variable cost has a mean of 20 and standard deviation of, say, 5. Okay. Then what I will do, I will go here. First, I generate a random number, correct? The first thing I will do, I will generate a random number. Let me go to a new page. The first thing I will do, I create a random number. So this is a random number. I don't know what it is. Each time I go here, delete, a new one comes. So this is a random number. Then I go equal to nor. So norm standard inverse. And then I say, okay, given the probability, what is z? That is z. Now I created a z. And I know that this z is equal to x minus mu divided by sigma, or x is equal to mu plus z times sigma. So this is equal to mu, which we assumed is 100 in our is what was it in this case, is 20 in this case. Z is equal to 20 plus sigma was 5 in this case, multiplied by the z value, and that's it. So now this is a random number with mean of 20 and standard deviation of 5. Okay. But we know a random number can also become negative. There is a probability that any random number becomes negative no matter what the sigma and mu are, because random variables go from negative infinity to positive infinity. To make sure that they will not be negative, I may say if this value is less than or equal to 0, type it. Or I can say this, let me say better than this. Equal to mean value of this one and 0. So whenever it becomes I can say max of 20 and 0. Now if it becomes negative, it will automatically come out 0. Right? Now I have a normal variable here. I will go there. Equal to mean, which is this one, lock it, plus standard deviation, which is this one, lock it, multiplied by norm standard inverse rand. This is a normal random variable between normal random variable with mean of 20 and standard deviation of 5, and then I copy it down just to make it more comfortable. I will round it to 0, so it will be rounded up or down but with no decimal point. Suppose sales price also follows normal distribution. So I come here, this one I make it B relative, and enter, copy it down, and paste it here, copy it, and then copy it here, and copy it down. Okay, here standard deviation cannot be AD, and I mean can be, but let's assume this has mean of 60 and a standard deviation of say 15. Okay, it is there. Let's see if we can observe any negative. Equal to count if the range is here, count if in that range less than 0. Less than 0. None. Fortunately, all of them are positive. Otherwise, we needed to write a function here that it is equal to max of 0 and that value to make it at least 0. Okay, now I have the price and the variable cost considered to be did I count that column or the other column? Yeah, that's good. Now let's assume quantity of cells follows exponential distribution. Let's see what is exponential distribution. Let's see what is exponential distribution. Exponential distribution is a distribution like this. Probability of small values are high, probability of large values are low. Suppose in this situation mu, which is equal to standard deviation in exponential distribution, is equal to 4,000 units, but it has exponential distribution. In exponential distribution, probability of an x to be greater than or equal to a specific x is equal to e to the power of negative x divided by mu. So this probability is equal to e to the power of x, which we don't know what it is, divided by 4,000 in this case. But we know something. We know that this probability is between 0 and 1. And we can find the random probability by generating a random number, which is between 0 and 1. Therefore, a random number could be equal to e to the power of negative x divided by mu. We know that if y is equal to e to the power of z, then ln of y is equal to z. We know that. So if we have y equal to e to the power of z, then ln of y is equal to z. Here we have rand equal to e to the power of negative x divided by mu. Therefore, ln of rand is equal to ln of rand is equal to negative x divided by mu. And therefore x is equal to negative mu multiplied by ln of rand. So in order to create an x from this distribution, all I need first to create a rand, and that is easy. Then compute the ln of that rand, then multiply it by negative mean. And that is what am I going to do right now. suppose sales has a mean of 4,000, but it has exponential distribution. So I go here, I type rand, that is my probability. I should compute ln of that rand, so I go here and I type ln and ln of that rand, okay? And then I multiply it by negative of mu and lock it, because I'm going to copy it down. Equal to rand, then ln of rand, and then negative of mu multiplied by ln of rand, and then copy it down. Just for simplicity, let's I think I didn't lock this one. This one should be locked. And then copy it down. And just for simplicity, integer it. Didn't need this one. So now these are my quantity produced, sales price, variable cost, and fixed cost. I have these instances. Now I should compute my profits. Contribution margin, that is price minus variable cost multiplied by quantity minus fixed cost. Here, enter, and copy it down. Copy it all, paste the special, paste it by value, these are my profits. These are sorted profits, right? And those percentages are still valid. Now I go and draw this chart. Insert, scatter, graph, that's it. Now probability of loss is much higher. Here you cut the 0 at 50%. If you look at over there, that probability, which we had it, and it's valid for the numbers here, it is quite high.